We all know about real numbers. Real number can be represented on a real number line or a number line. A number line is something which is nothing but a straight line having a 0 on it, and on the right hand side it increases on equal intervals and we get positive numbers on this line. Now I'm depicting the natural numbers here, that is 1, 2, 3, 4, 5, and on the left hand side it decreases in equal intervals having values what I'm writing here. But there are other values on the real number line, which is in between the natural numbers. We get certain values like 1.5, or that can be written in fraction as 3 by 2. And there are other kind of values, something like root 2, which has the value approximately equal to 1.41. But that is not the exact value, that is the approximate value. So numbers like root 2, pi, root 3, root 7, these numbers are irrational numbers. If we try to write these irrational numbers in a decimal form, so decimal form of irrational numbers are non-terminating and non-repeating. We can say that irrational numbers cannot be written as a fraction. So it cannot be written as p by q. But then there are rational numbers which can be written as in the form of p by q or can be written as in fraction. And also the decimal form of irrational numbers are either repeating but not non-terminating or terminating. The examples I can quote here, like repeating but not terminating is something like 3.333. So it is not terminating but repeating, and then terminating decimals are 2.5, 2.25, minus 3.75, something like this. Now real numbers is a really big family. It includes all the rational numbers and all the irrational numbers. Okay, and that can be represented on a number line. But there are numbers which are not real numbers. So we are going to learn something like that in this video. As you know about the real numbers, that if we square any real number, so if we square any real number, we always get a positive value. All right? But what about equations like this? X square plus 1 is equal to 0. So if this expression x square plus 1 is equated to 0, then our x square gives the value x square is equal to, this plus 1 goes on the right hand side, it becomes minus 1. So square of any number cannot be minus 1. This is, or cannot be a negative number. This we know from our previous study, but there are possibilities. So during the 17th and 18th century, mathematicians developed one different kind of number, which is called complex number. They call it that if for this equation, if we further find the square roots of both sides, we get the value under root of x square is equal to under root of minus 1. And then we cut the square, cancel the square with the root, and then we get x is equal to under root of minus 1. So under root of any negative number is called imaginary number. This particular number under root minus 1 is called imaginary unit. And the name of this number is iota. And for the given problem, iota is the solution of the equation. Including this kind of numbers in our study, the mathematician developed a new kind of number. And this is the biggest family of numbers possible. So it includes everything, all the numbers you know till date, be it natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers. And this big family is called the family of complex numbers. A complex number is represented by Z, and that is equal to A plus IB. Here, A and B are the real numbers. As you can see, the real number A has no I multiplied to it. We call this part of the complex number the real part. And then we have another part of this complex number which include iota, and we call this part the imaginary part. And then any number can be written in this form. For example, Z is equal to 2 plus I3. This is a complex number where 2 and 3 are real numbers, and 2 is the real part of this complex number, and iota 3 is the imaginary part of this complex number. The numbers like 7, minus 5, or minus 9 by 4, all these numbers are also complex numbers because complex numbers include all the numbers. We can write these numbers in the form of complex number. So we can write Z is equal to 7 plus iota multiplied by 0, which is nothing but 7, but it is a way to show that any number, so 7 is a natural number or a whole number or an integer, and it can be written in the form of a complex number. Likewise, minus 5 can be written as minus 5 plus iota multiplied by 0 or I0, and this is the representation of minus 5 in the form of complex numbers. And then we have minus 9 by 4 plus I0 is the representation of minus 9 by 4 in the form of complex numbers. In this way, you can see that any number can be written in the form of a complex number. We can take some irrational numbers as well. So your Z can be root 2 plus iota 0, and this is nothing but representation of root 2 in the form of a complex number. So if Z is equal to A plus IB, then real part of Z can be written as REZ is equal to A, and the complex or the imaginary part of the complex number Z can be written as IMZ, that is equal to B. If two complex numbers are given, suppose Z1 is equal to A plus IB and Z2 is equal to C plus ID, then if we have to add these two numbers, Z1 plus Z2, we will always add the real part of Z1 to real part of Z2, and then we will add the imaginary part of Z1 to imaginary part of Z2. Let's take one example. So given that Z1 is equal to 6 plus I3 and Z2 is equal to 2 minus iota. Now if we have to find Z1 plus Z2, then we will add the real parts together. So real parts are 6 and 2, so we will add 6 and 2 together, and then we will write iota and we will add the real parts together. So real part is 3, and here minus 1 is hidden here because minus sign, you can see the minus sign. So it will become 3 minus 1. And what do we get? We get 6 plus 2, 8 plus iota, and 3 minus 1 is 2. So our Z1 plus Z2 is 8 plus I2. If Z1 is given A plus iota B and Z2 is given C plus iota D, and if A is equal to C and B is equal to D, so A is equal to C and B is equal to D, in that case we can say that Z1 is equal to Z2. So both the complex numbers are same or equal. Now the sum of two complex numbers, Z1 A plus IB, Z2 C plus ID, the general formula I've already given you, and to make it more general or generalize it better, I can write Z1 plus Z2 is equal to real part of A plus real part of B. So real part of A, Z1 is A, and real part of Z2 is C. So we can write A plus C and then plus sign, then iota, and then imaginary part of Z1 and imaginary part of Z2 is added. So B and D is added. So we'll write B plus D. And this is the sum of two complex numbers. Further, adding two complex numbers like Z1 and Z2, so they give certain properties. So there are certain features or certain properties of addition of two complex numbers. Let's see what all properties can be satisfied when we add two complex numbers. The first one is the closure property or closure law. So it says that given Z1 is equal to A plus IB or Z2 is equal to C plus ID, or any two complex numbers, when added, we get a new number, that is Z1 plus Z2. So this is also a complex number. So the sum of two complex number is a complex number. That is called the closure property. Or we can say Z1 plus Z2 is a complex number if Z1 is a complex number and Z2 is a complex number. The second property is the commutative property. Or commutative law. It says that if we add two complex numbers Z1 plus Z2, the order of addition is of no importance. That is simply the order of addition won't change the result. So either we can write Z1 plus Z2 or we can write Z2 plus Z1, and these are equal numbers. They both are the same complex numbers. And the third one is the associative property. What it says that, associative property or associative law, it says that if there are three complex numbers, so Z1, Z2 and Z3, so it doesn't matter which one is added first, which two is added first, and then we add the third one. So we can write Z1 plus Z2 is added first, that's why it is in the bracket, and then Z3 is added, and we find a complex number. This complex number is actually equal to Z1 plus if Z2 and Z3 is added first and then Z1 is added. So again, the order of addition is of no importance here. And that's your associative law. And then we have the fourth one, that is the existence of additive identity. It says that if a complex number A is added to, if a complex number Z is added to 0, it remains Z. So there is no change in the complex number if it is added to 0. We can just elaborate it. So Z can be written as A plus IB. If this is added to 0, or 0 can be written as 0 plus iota 0. So it will remain the same because the real part is 0, the imaginary part is 0. So if it is added to A, it will remain A. If it adds to B, it will remain B. And our complex number A plus iota B won't change. So that is the proof that there is the existence of additive identity. And then there is a last additive property or law is the existence of additive inverse. This is quite interesting. So there is one additive inverse of a complex number. So if z is equal to A plus iota B, there is something called minus z, which is nothing but just negate the whole complex number. And what it will happen is, if we open the brackets, it will become, real part will become negative of, or the opposite sign of what it is before, and then the imaginary part will also have a negative sign. So minus z is this, and it simply means if we add the complex number to its additive inverse, we will get 0, and that's the property of existence of additive inverse. Now with this I take a break here, and I will come back with the next topic, that is the multiplication of complex numbers, and we'll take it further. So thank you for watching. Stay tuned. Bye.